Hi all, in this video I am going to explain the most important MCQs of control system under SET2. I have given the link for SET1 in the description box. So first of all, the problem number 21. The solution of x dot equal to a of t into x of t is. So x dot equal to a of t into x of t. First of all, I am going to write x dot as dx by dt minus a of t into x of t equal to 0. So I have to write d by dt as m. So m minus, or d, I have to use m minus a of t into x of t equal to 0. Have to take a of t as a. M minus a equal to 0. So what is the complementary function? Complementary function is equal to x of t, that is equal to e power at into b. B is the constant. Next I am going to find out the constant. Put t is equal to 0. X of 0 equal to e power 0 equal to 1. So b. So what is the answer? The answer is x of t equal to e power at, capital A or small e power at into x of 0. So x of 0 is written as x naught. So the answer, the first one is correct. And next I am going to explain the problem number 2. In this 22, in the signal flow graph of the figure, y by x equal to. So see the signal flow graph. First of all, I am going to calculate how many forward paths. So this is the forward path in the signal flow graph. What is forward path? The signal is starting from x and ending at y. That is known as forward path. Here, this signal flow graph consists of only one forward path. The forward path is taken as P1 of 5 into 2 into 1. The answer equal to 10. And next I am going to find out feedback loop. See what is feedback loop? Here the incoming node and it consists of the outgoing node. So both in the same node, that is known as feedback loop. So what is feedback loop here? Feedback loop consists of the gains 2 and minus 2. So 2 into minus 2, the answer is minus 4. What is the transfer function or what is the gain of the signal flow graph? That is P1 delta 1 divided by delta. So what is P1? P1 is the forward path. Delta 1 is 1 minus delta. It is equal to delta. But the loops are not touching in the kth forward path. Here the loop, only one loop is presented here. The loop is touching in the kth forward path. That is first forward path. So the value equal to 0. Whole divided by, what is delta? 1 minus sum of individual loop, 4. Okay, now 10 divided by 1 minus of minus 4, that is plus 4. The answer is 2. So the answer 2 is the correct one. Option C is the correct answer. Next I am going to explain the SET2 linear time invariant system as the state and output equations given below. x1 dot x2 dot equal to 1 minus 1 0 1 x1 x2 and 0 1 u. Then y is equal to 1 1 x1 x2. If x1 of 0 equal to 1, x2 of 0 equal to minus 1, u of 0 equal to 0, then dy by dt at t is equal to 0 is. Okay, here I am going to find out dy by dt at t is equal to 0. First of all, from the equation I am going to write x1 dot. So what is x1 dot? x1 dot equal to 1 into x1 minus 1 into x2 plus 0. 1 into x1 minus 1 into x2 plus 0. And what about x2 dot? x2 dot equal to 0 into x1, 0. 1 into x2. So x2 plus u, that is x2 dot. Then from this, what is y? Y is equal to x1 plus x2. From this equation y, I am going to find out dy by dt. What is dy by dt? That is dx1 divided by dt plus dx2 divided by dt. Already we know the value for dx1 by dt and dx2 by dt. So this is dx2 by dt. Now I have to substitute here dy by dt equal to, what is dx1 by dt or x1 dot? That is x1 minus x2 plus 0. And what is dx2 by dt or x2 dot? x2 plus u. So the answer is x1 plus u. That is dy by dt. I am going to find out dy by dt at t is equal to 0. So what is the answer? Dy by dt at t is equal to 0, that is x1 of 0 plus u of 0. What is x1 of 0? 1. What is u of 0? 0. So the answer is 1. So option A is the correct answer. Our next problem, the number of roots s cube plus 5s square plus 7s plus 3 equal to 0 in the left half of the S plane. So how to find out this? Using Rao's stability criterion, I am going to find out how many roots in the left half of the S plane. So Rao's stability criterion. First of all, write s cube, then s square, then s power 0. So s cube is 1, 7. Then s square 5, 3. So now I am going to multiply this, cross multiply this. So 35 minus 3 divided by 5. So what is 35 minus 3 divided by 5? That is equal to the positive value. So 32 by 5. So 6.4. So 6.4. And now 6.4 is multiplied with 5. 6.4. 0 is multiplied. 6.4 is multiplied with 5 minus 0 is multiplied with, have to put the value here. So this is the answer 6.4. Now the 6.4 is multiplied with 3 minus 0 into 5 the whole divided by 3. The 6.4. So the answer may be 3. So see the first column of the row array, all the elements are positive. So all are positive. So number of roots is, the maximum power is the number of roots. There are 3 roots. So the answer is 3. So 3 is the correct answer. And next problem, 25. The transfer function of a tachometer is in the form. The four options are given: Ks, K by S, K by S plus 1, K by S into S plus 1. In a tachometer, the voltage E1 is directly proportional to the angular velocity omega m. Our output is directly proportional to the angular velocity omega m. So from this, I have to find out EI equal to one added one constant here, KT into omega. So what is omega KT into d theta by dt? Next I have to take a Laplace transform. EI of S is equal to KT into S into theta of S. What is EI of S divided by theta of S equal to KT into S. So that is the correct answer. K into S or KT into S. Option A is the correct answer. And the next problem, problem number 26. Consider the unity feedback control system with open loop transfer function G of S is equal to K divided by S into S plus 1. The steady state error of the system due to a unit step input. So first of all, I am going to write the steady state error due to step input. So ES is equal to 1 divided by 1 plus Kp. And what is Kp? Kp is the positional error constant. How to find out this? Limit S tends to 0 into G of S. So limit S tends to 0. What is G of S here? G of S is equal to K divided by S into S plus 1. Have to put 0 here. 0 into anything that is 0. So K by 0 equal to infinity. So what is ESS? ESS equal to 1 plus 1, 1 by 1 plus infinity. So the answer may be 0. So what is the answer? That is the option A is the correct answer. And next, the problem 27. The transfer function of a zero order hold system is. So what is zero order hold? See, this is the zero order hold. 0, this is t. So how to write this equation? U of t, here u of t, here t, u of t minus u of t minus t. Then take the Laplace transformation, zero order hold. 1 by s minus e power, for this e power minus st by s. How to write this? 1 minus e power minus st divided by s. So 1 minus e power minus st divided by s. Option B is the correct answer. And next problem 28. In a Bode plot of unity feedback control system, the value of phase of G of omega at the gain crossover frequency is minus 125. The phase margin of the system. What is phase margin? Phase margin is 180 plus pi gc. That is the phase margin. Here what is phi gc? Gain crossover frequency. So gain crossover frequency, that is 125 degree is given. 180 minus 125 degree. That is equal to 55 degree. So 55 degree is the phase margin. So option C may be a correct answer. And next problem, problem 28. 29. The transfer function of a phase lead control is 1 plus 3Ts divided by 1 plus tau. The maximum value of phase provided by the controller is. So first of all, I am going to write the standard equation transfer function of the phase lead compensator. The phase lead compensator, what is the standard transfer function? That is S plus 1 by tau divided by S plus 1 by alpha tau. So 1 plus tau is divided by tau, 1 plus alpha tau is divided by alpha tau. Okay, alpha into 1 plus tau is divided by 1 plus alpha into tau. Now I am going to equate this equation. The equation given by 3Ts divided by 1 plus Ts. Here 3Ts, tau is equal to 3T. And what is alpha tau? Alpha tau equal to T. So 1 by 2. So 1 by 2 equal to what? 1 by alpha equal to 3. What is alpha? Alpha equal to 1 by 3. Here I am going to find out maximum value of phase. Phase is 5. How to find out maximum value of phase? Maximum value of phase equal to is sin phi m equal to 1 minus alpha by 1 plus alpha. This is the formula used to find out the phase. Minus alpha, that is 1 by 3. 1 plus 1 by 3. So what is this? 2 by 3 divided by 4 by 3. If we cancelling this, we get the answer 2 by 3, 3 by 4, 1 by 2. So what is sin phi m? Yes, sin phi m is 1 by 2. What is phi m? Sin inverse of 1 by 2. When we get 1 by 2, sin 30 degree. So when sin 30, at that time we'll get the value 1 by 2. So 30 is the correct answer. So option D is the correct answer. Our next problem, the transfer function of the system is 2s square plus 6s plus 5 divided by s plus 1 the whole square into s plus 2. The characteristic equation of the system. How to find out the characteristic equation? The formula is 1 plus gs equal to 0. 1 plus, what is gs? 2s square plus 6s plus 5 divided by s plus 1 the whole square into s plus 2 equal to 0. Now I cross multiplied this. So s plus 1 the whole square into s plus 2 plus 2s square plus 6s plus 5 equal to 0. So what is the option? Option C may be a correct answer. Next I am going to explain the next problem, problem number 31. In a synchro error detector, the output voltage is proportional to omega of t the whole power n, where omega of t is the rotor velocity and n equals to theta r minus theta L, that is equal to C. Okay. output voltage V is equal to directly proportional to omega of t the whole power n, and this is constant, the value equal to 1. Next problem, for a second order system with closed loop transfer function t of s is equal to 9 by s square plus 4s plus 9. The settling time for two present band in second is. First of all, I am going to find out omega n and zeta. For that, I am going to take a general transfer function of the second order system. Have to write the general transfer function. What is the general transfer function? Omega n square divided by s square plus 2 zeta omega n s plus omega n square. Now I am going to equate both the equations. I will get the answer omega n square equal to 9, omega is n is plus or minus 3. I have to take plus 3, and now I am going to equate 2 zeta omega n equal to 4. I have to cut this. Zeta equal to 2 by 3. And next, 2 percentage band. For a 2 percentage band, the settling time equal to Ts is a settling time. 4 zeta omega n. 4 divided by zeta omega n. What is zeta? Zeta is 2 by 3. Omega n is 3. 3 cancel. The answer is 2. So what is the settling time? The settling time is 2. 2 is the correct answer. Next, we can see the problem number 33. The gain margin of a system having loop transfer function is. So how to find out the gain margin? The gain margin equal to 1 divided by the magnitude at phase crossover frequency. So first I am going to find out the magnitude. So magnitude of g of j omega. We will convert this into sinusoidal transfer function by substituting s is equal to j omega. So root 2 the whole square. Again we get root 2 divided by, have to convert this first, root 2 divided by j omega plus 1. So square root of omega square into omega square plus 1. Divided by omega square root of omega square plus 1. So this is the magnitude. So after getting the magnitude, next I am going to find out the phase crossover frequency. For finding out phase crossover frequency, I am going to find out angle of g of j omega. So when the phase is equal to, or angle of g of j omega is equal to minus 180 degree, the frequency occurring is known as phase crossover frequency. When the phase is equal to phase crossover frequency, angle of g of j omega is minus 180. So from this I am going to find out the phase crossover frequency. What is j omega? Minus 90. Here what is the angle here? Tan inverse b by a. B is omega. B by a is 1. So that is equal to minus 180. From this, what is minus tan inverse omega? That is minus 90. Cancel. And what about omega? Omega is equal to omega pc equal to infinity. Tan inverse omega is 90. Tan of 90 is what? Infinity. Now what is gain margin? Gain margin is 1 by magnitude. So what is the magnitude? 1 by root 2 by omega, the square root of omega square plus 1. Have to substitute here omega equal to omega pc. So root 2 divided by, what is omega pc? Infinity. So what is root 2 by infinity? That is 0. So what is 1 by 0? Again infinity. So gain margin equal to infinity. So the answer is infinity is the correct answer. Option D is correct. Then the phase margin of a system having the loop transfer function g of s into h of s equal to 2 root 3 divided by s into s plus 1. Here I am going to find out phase margin. So what is phase margin? Phase margin is 180 plus pi gc. That is phase margin 180 plus pi gc. Here, what is pi gc? Angle of pi, angle of g of j omega at gain crossover frequency. So first I am going to find out the gain crossover frequency. How to get the gain crossover frequency? When the magnitude of g of j omega is 1, the frequency is known as gain crossover frequency. So first of all, I am going to find out the magnitude of g of j omega. So that is 2 root 3, there is no change, divided by omega, square root of omega square by omega square plus 1. So that should be equal to 1. Now take square on both sides of equation, 4 into 3, and cross multiply this omega into omega square plus 1. So omega power 4 plus omega square minus 12 equal to 0. So omega square minus 4, plus 4, omega square minus 3 equal to 0. So from this equation, omega equal to plus or minus j2. Another one answer, omega equal to plus or minus root 3. This omega is the correct answer. So this is omega gc root 3. Okay. Now I have to substitute this omega gc into angle of g of j omega. So angle of g of j omega is what? Minus 90 minus tan inverse omega. Okay. Minus 90 minus tan inverse what? Tan inverse root 3. Have to substitute this. What is tan inverse root 3? Tan inverse root 3 equal to tan inverse root 3, that is minus 90, sin 30 is 1 by 2, cos 30 is root 3 by 2, wrong, sin 60. So minus sin 60. So minus 150 is the correct answer. But what is phase margin? Phase margin is 180 minus 150. The answer is 30 degree. So 30 degree is the correct answer for this problem. So this is the phase margin. Next problem. If a closed loop transfer function T of S of a unity negative feedback system is given by, then the steady state error for the unit ramp input. So what is the steady state error? ESS is 1 by kV. How to find out kV? Limit S tends to 0, S into G of S. So limit S tends to 0, S into G of S is what? An minus 1 into S plus An divided by S power n, A1 S power n minus 1, An minus 1 S plus An. Now I have to put 0 here and S will be 0. So limit S tends to 0, 0 into the multiple of anything that is equal to 0. So kV equal to 0. So if we substitute kV equal to 0, and I'm going to find out ESS, no. So ESS equal to steady state error for the unit ramp input. Is 0, sorry. So the answer may be 0. Problem 36. Consider the points S1 equal to 3 minus 3 plus J4 and S2 equal to minus 3 minus J2 in the S-plane. For a system with open loop transfer function, G of S into H of S equal to K in divided by S plus 1 the whole power 4. So first of all, I am going to find out the characteristic equation. So 1 plus G of S is equal to 0. 1 plus G of S into H of S. 1 plus K by S plus 1 the whole power 4 equal to 0. So S plus 1 the whole power 4 plus K is equal to 0. Have to expand this S power 4 plus 4 S power S cube plus 6x square plus 4s plus 1 plus k equal to 0. Now I am going to apply the root stability criterion in order to find out the stability. S square S power 0 1 6 1 plus k, then 4 4 4 S 4 4 0. Have to multiply, so 24 minus 4 divided by 4, that is 5. Then 4 into 1 plus k, 4 into 1 plus k divided by 4, that is also 1 plus k. Then 20 minus 4 into 1 plus k divided by 5. 20 into this, 0 into this, divided by 20 minus 4 into 1 plus k by 5, that is equal to 1 plus k. Okay, now I am going to find out the stability condition. For the condition for stability, 1 plus k, that is greater than 0. So k is greater than minus 1 from this. And next 20, take this one, 20 minus 4k is greater than 0. 16 is greater than 4k. K is less than 4. So it is maybe minus 1 is less than 4. Here root locus crosses the imaginary axis. We have to find out in which point root locus crosses the imaginary axis. So for finding this, I am going to take this equation. So 5s square plus 1 plus k equal to 0. So the answer is 5s square plus 1 plus 4 equal to 0. So 5s square plus 5 equal to 0. S square equal to plus or minus j. So root locus crosses the imaginary axis minus j and plus j. Here all the holes are minus 1. S is equal to minus all the 4 holes. Here 4 poles are there. 4 poles, all the poles are equal. -1. This crosses the imaginary axis like this. Okay. So, -3 plus J4 -3 minus J2 both are neither S1 nor S2 is on the root locus. That is the correct answer because the poles are -1 only. And it crosses at plus or minus J. And next problem number 37. For the system described by the state equation x dot equal to 0, 1, 0, 0, 0, 1, 0.512, 0, 0, 1. If the control signal u is given by u is equal to -0.5, -3, -5 into x plus v, then the eigenvalue of the closed loop system will be. Here I am going to find out u. So u is equal to what? That is -0.5, -3, -5 into x plus v. So from this, what is x dot? So x dot equal to what? X dot equal to 0, 1, 0, 0, 0, 1, 0.512 into x plus 0, 1, 1 minus 0.5 minus 3 into x plus v. Okay. Now I am going to multiply this 0, 1, 0, 0, 1, 0, 0, 1, 0.512. Okay, then I have to multiply this. Here this is 3 cross 1. Row is 3, column 1. Here this is 1 cross 3. So we get 3 cross 3 matrix finally. So 0 into this one. So that is 0, 0, 0. And next also, 0, 0, 0, 0. Next we get minus 0.5, minus 3, minus 5, x plus v. Now I am going to add this 0, 1, 0, 0, 0, 1, minus 0.5 plus 0.5 again 0, and 1 and minus 3 minus 2, 2 and minus 5 minus 3, x plus v. So this is the new x dot. The question is, then the eigenvalue of the closed loop system. Here I am going to find the trace of the matrix. So what is this trace? 0 plus 0 minus 3. If we add all the eigenvalues, I will get minus 3 means that is the correct one. So option A minus 3, option B minus 4, option B minus 4, option C minus 4, option D minus 2. But the option A only gives minus 3. Option A is the correct answer. Next problem 38. The Z transform of the signal is given by C of Z equal to Z inverse into 1 minus Z power minus 4 divided by 4 into 1 minus Z power minus 1 the whole square. Its final value is. How to find out the final value? The formula to find out the final value is limit Z tends to 1, Z minus 1 by Z into C of Z. Okay, limit Z tends to 1, Z minus 1 by Z Indice of z is z inverse 1 minus z power minus 4, 4 into 1 minus z power minus 1, again 1 minus z power minus 1. And next I am going to take z power minus 1, the z power minus 1 into, I will take z power minus 4. So inside I am having 1 by z power minus 4, that is z power 4, then minus 1. In the denominator also 1 minus z, I have to take z power minus 1 from the both equations, z power minus 1. So z minus 1 into z minus 1. So z minus 1 by z into z minus 1 into z minus 4 divided by 4 z power minus 2. Here z power 4 minus 1 I have to rewrite as z square minus 1, a minus b into a plus b, z square plus 1 divided by z minus 1 the whole square. So one of the z minus 1 is cancelled by the z minus 1. So z here z have to expand this. So z power minus 5 divided by 4 into z power minus 2, and then that is again into z square plus 1, z plus 1 into z minus 1. I have to expand this one divided by z minus 1. Both are get cancelled, and I have to cancel this z power minus 3. So finally I get 1 by 4 z cube into z square plus 1 into z plus 1. So what will be the answer? The answer may be z square plus 1, 1 plus 1, 2, 1 plus 1, 2 divided by 4. So limit z tends to 1. So the answer is 1. 1 is the correct answer. Option C is the correct answer. Then next problem, the characteristic equation of the closed loop system, then the system is. So characteristic equation is given, that is a square plus 2s plus 2 equal to 0. What is the standard equation, characteristic equation of the second order system? 2 zeta omega n plus omega n square equal to 0. Omega n is equal to root 2. And what is zeta? Zeta equal to 2 zeta omega n equal to 2. So what is zeta? Zeta is 1 by omega n, 1 by root 2. 1 by root 2 is what? Denominator numerator by root 2. Root 2 is 1.414 divided by root 2 into root 2, that is 0.707. So 0.707 zeta is less than 1. So the value, that is underdamped system. The system oscillation is underdamped. Option C is the correct answer. Next, the last problem, the problem number 12. The root locus diagram for the closed loop feedback system is shown in figure. The system is overdamped. The system is overdamped, that is given. From this, I am going to find out the condition when the system is overdamped. So for this, I am going to write the characteristic equation 1 plus g of s into h of s equal to 0. So from this, how many poles and zeros? 1 pole, second pole and 1 0. 2 poles and 1 0. So first of all, I am going to write, this is not 0. Yes, yes, one of the 0. Sorry, this is 1 pole and this 1 pole. 2 pole and 1 0. Have to write g of s first. G of s equal to k into, I'm going to write the 0, s plus 3. Then write the poles, that is s plus 1 into s plus 2. 1 plus k into s plus 3 divided by s plus 1 into s plus 2, that is equal to 0. So to write this, cross multiply this, s square plus 3s plus 2 plus ks plus 3 equal to 0. S square plus have to combine the s terms. So 3 plus k into s plus 2 plus ks plus 3k. 2 plus 3k equal to 0. So what is the standard second order equation? The standard second order equation is s square plus 2 zeta omega ns plus omega n square equal to 0. From this, what is omega n? Omega n is square root of 2 plus 3k. And what is zeta? 2 zeta omega n is equal to 3 plus k. So from this, theta is equal to 3 plus k divided by 2 into omega n 2 plus 3k. But what is the condition? System is overdamped and this stable system. Theta is greater than 1. So 3 plus k divided by 2 square root of 2 plus 3k, that is greater than 1. Taking square on both sides of the equation, so 3 plus k the whole square greater than 4 into 2 plus 3k. So 9 plus 6k plus k square is greater than 8 plus 12k. So the answer, so that is 9 plus k square, you have to write it first, plus 6k minus 12k, that is minus 6k plus 1. 9 minus 8 plus 1 equal to 0. So k square minus 6k plus 1 equal to 0. Have to use the minus b plus or minus square root of b square minus 4ac by 2a. Have to substitute this, so minus 6 plus or minus square root of 36 minus 4 divided by 2. So select plus or minus root of 32 by here 2. So the answer may be 5.82 and next one is 0.17. So what is the condition here? From the four options, which one is correct? The option number D is correct. Here the 0.17 is between 0 and 1, correct? And 5.82 is that is more than 5. So this option is correct. So option D is the correct answer. Thank you. Have a nice day.